Hello everybody! Can I introduce you to a fun and practical way to experiment with electronics? The system is called Lectron. This is the manual and it's very detailed. There's also a power supply included and many components inside cubes. These cubes can be easily mounted on the included metal surface. For instance, let's take a resistor block. You can see the schematic symbol together with the value on a white label. Now, when you turn it over, you can see that the casing is transparent and you can actually see the component inside. It's very cool. These are the contact plates for a resistor and there are also magnets underneath. So, when you put the cube on a metal surface, it holds there thanks to the magnet. Now, let's take another resistor cube on a 5.6K. When you hold them together, they attract each other thanks to the magnet and they make contact. Now, these are the magnets to hold these resistor cubes on the metal surface. Alright. Now let's move on with the transistor. This is a transistor. It has the base connection, the collector and the emitter, and this is the magnet to put on a metal surface. Alright. Now, if we want to ground our transistor, we need a special block. It's the ground block. So, you see the ground symbol on it. And the side of the block is connected with the bottom of the block, which makes contact to the metal plate or ground. Now we can say that our transistor is grounded. So when you want to build up your circuit, it's easy to use these ground blocks to spare some time and for easy assembly. Now let's move on with the electrolytical capacitor. This capacitor is polarized, which means that you have to pay attention to put it properly in your circuit. Okay, alright. Now, we need some power to power up our circuit, so we have a battery block here. This battery block is 9 volts, there's a plus and a minus connection. These are the connections at the sides, and the battery is inside the case, which can be easily be opened. Right. Or we can use a bridge rectifier, and it has also the plus and the minus of our battery block. But it has also an AC or alternate current connection of 12 volts. At the side you find the plug for your power supply. And this little socket. Now there's also a small adjustment for our DC output and it can be adjusted between 2 and 12 volts. Alright. Now, let's move on with some other components. For instance, this is a transformer, but in this case it's a medium wave coil for medium wave reception. This is a relay block and has 2 separate contacts, and this is the coil of the relay. If you want to hear some sound in your circuit, you need a speaker. This is the speaker block. It has a transformer inside and a speaker. So there you actually see the speaker, and this is a transformer, and these are the 2 magnets to hold the speaker on a metal surface. Okay. This is the meter, and it's a very cool. You can see it can deflect to the right and to the left, which means you can connect it either way. This is the meter inside. This is the potentiometer, and it's a potentiometer of 10K. So we can adjust here. Right. Okay, now if you want to connect your circuit, you need some wiring. These are the wire blocks. You see these opposite sides are connected with each other. This is the magnet to hold on the magnetic surface. We have also a T connection. This is a T connection which makes contact with 3 sides of the cube. And also the magnet here. What's next is the corner block. This connects 2 sides of the cube. We have a crossing wire here, but these intersections are not connected, as you can see. there's no dot. We have also a cross wire, but intersections are connected with each other. There's the dot. So the four sides are connected with each other. Okay, what have we next? This is a transformer and it can produce high voltages. This voltage can be measured with a neon light. This is a neon bulb. This is a variable capacitor and other components to be used in various circuits. Now, I would also like to mention the light bulb. It has connections at the side of the cube. The lamp itself can be used as a light indicator or even as a small resistor, as proposed in our following 3-stage amplifier circuit. So stay tuned and let's get started. Now it's time to use these cool Lectron modules for building a good working 3-stage amplifier. Amplifier consists of 3 stages: the pre-amplifier, end amplifier and the speaker box. All cubes are arranged in a logical way from input to output. So, let's start with the input. We use the DIN modular. This DIN modular has a connector at the sides, where we can connect our smartphone or music device. The center of the DIN modular is grounded for easy assembly. Let's put it in the left bottom corner. So, now, we need to adjust our inputs, so we need a potentiometer. This is the potentiometer cube. It has 3 connections and a shaft to adjust the potentiometer. So, we put it this way. Right, now we need to connect the DIN modular to our potentiometer, so we use a corner block. These sides are connected with each other. Now we need also to ground the potentiometer, so we use the ground block. This is a ground symbol. The side and the bottom of the block are connected to the metal port. So, to separate our inputs to our first amplifier, we need a capacitor. And we use this capacitor of 0.47 microfarads. It can be mounted either way. So, now to make connections to our first transistor, we use a T-block. It has 3 connections connected with each other. So, now we are going to use the first transistor. It is an NPN transistor. So, this is the base of the transistor, the emitter and the collector. And this is the transistor. So, we put it this way. Now we need also to ground the emitter of our transistor, so we use also a ground block. Okay, now the emitter is grounded. To bias a transistor, we need a resistor. So let's use the 100k resistor. This is the 100k resistor cube, and it's connected at this and that side. We mount it here in our circuit. So now we need some more connections. For that reason, we're going to use some T-blocks. This is a T-block. We put it here, and this goes to the next stage of our amplifier. So we need to make connections here. We use 2 more T-blocks. As you might see now, the current can flow through the resistor to the base, and the bias is being done. Now, this needs a feedback resistors So we use a corner block here. This is the corner block. And we put it this way. So we add two resistors here to make feedback later on. We use a 10K and a 5.6K resistor. These can be mounted this way or even that way. It's the same. Later on we will add some more blocks here, but that's for later. Let's continue with it. Right, now to make our transistor work, we need to connect it to the power rail by using a resistor. We use the 4.7K resistor and we place it here. Now current can flow through this resistor, through the 100K resistor to the base of our transistor, and it should work. Now we need a voltage divider here, so we're going to use some wiring first. We use the T block here, followed by a straight line block. Now current can flow through our transistor. This T block, in fact, it is just a straight wire between these connections. Okay, now we have to use a resistor for our voltage divider. We use a 220 ohm resistor, and this is the way it is connected. Okay, let's continue now with the wiring. Okay, now we're going to use a T block. Now, if the power is applied here, the resistor is a filter for a circuit of our preamplifier. To smoothen it, we need some capacitor, so we use the 100 microfarad capacitor. Pay attention to correct it properly with a plus and a minus. Now we need to ground the minus of our capacitor, so we use the ground block. Now the resistor acts as a ripple filter and the capacitor stores the energy. So let's continue with powering the circuit. We need a straight line block here. Followed by the power source. We can use the battery block of 9 volts, with the minus and the plus. Or we can use the bridge rectifier. It has the same connections, plus and minus. And this is the connection for a power supply to the wall socket. But in this case we are going to use the battery. So we snap it together here. If we want to make our circuit work, we need to ground the negative pole of the battery. We can use a ground block later on. We put it at the side. Now let's move on to the next stage of our amplifier. First of all, we will use a straight line block for a power supply. Now, to separate the second amplifier from the first, we need decoupling capacitor. We use the capacitor of 10 microfarads and we pay attention to mount it properly with the plus this way. Just pushing the blocks a bit here. Now, to connect the capacitor to the second transistor, we firstly going to use a cross block. This cross block has 4 connections and each connection is connected with each other with a dot. We place it here. Now we're going to use the second transistor. It's also an NPN transistor. This is the base, the emitter and the collector. We put it here. Alright. Now we need also to ground our emitter of our transistor. So we use the ground block. The next step is to add a capacitor between ground and base of our transistor to avoid oscillations. We use the 47 nanofarad capacitor and it can be mounted this way or the other way, it's the same. So we're gonna mount it this way, and we use a ground block to ground it to the chassis. To bias our second transistor, we need also a resistor. So we're going to use the 100K again. It's a 100K resistor. And we mount it here. We continue with some wiring. We use the straight line block. And now we have to use some T connections to make the bias work. We use the T blocks and we place it this way. Now, the current can flow through the 100K resistor to bias our transistor, so it should work. This will continue to the next stage. This time we're going to use the lamp. The lamp is only used as a small resistor. So, now to couple our second transistor to the third transistor, we need a decoupling capacitor to separate the power supply. We use the 10 microfarad capacitor and pay attention to the plus. We mount it so this way. Now we need to connect a resistor here and we place a 1.5K resistor. Now let's connect this to the third transistor. So we're going to use some wiring first. This is a T block to connect the speaker afterwards. Okay. This is a third transistor and we're gonna put it here. So the two transistors are in series now. We're going to use a T block here to connect the base. And we need also a bias here, so we're going to use a bias resistor of 100K. To connect this to the power supply, we need a T block again, so we are going to use it. So, now this is the connection of the speaker. So we need also a T block here to connect our speaker box to the plus of our battery. This is the corner block. Finally, time to add a speaker. So you see, this is a T with a transformer connected this way. We're gonna place it here. Now, to connect our speaker box to the amplifier, we need to use a capacitor of 100 microfarad and pay attention to the plus. We put it here in our circuit. Next, we have to use a corner block to connect the capacitor to the speaker box. So, now it's time for the second phase. We need to make a feedback connection. So stay tuned. Although our amplifier is working now, it has stability issues and distorted sound. To resolve these problems, we're going to use a feedback loop between the output and the inputs to make the circuit stable. So, for this reason, we're going to use a special Lectron cube, and it has two connections. One at the right and one at the left. The right connection makes contact to the circuit by the metal plate at the side of the cube. The left connection is a connection to the ground. So, now we can have to add a wire. This wire has two little jacks of 2 millimeters, but they can easily be inserted in holes on top of the cube. For instance, we are going to use the right connection to make connection to the circuit. We put it next to the resistors. The other end of the wire we have to insert between the cubes. So we are going to use a special plug. This plug is very thin and can easily slip between two cubes without breaking the circuit and making contact. Now this is the hole on top of it where we can introduce the wire. Now we're going to slide it between adjacent cubes and the contact is made and our feedback loop is working. This is how it works. When the input rises, the output rises also, but the feedback lowers the input, so stabilizing the overall gain of our amplifier. Don't forget to put the ground block to the battery to make it. The input of our amplifier must be connected to a smartphone or an MP3 player, so we can actually hear the music through the Lectron system. For this reason, we use a special cable. This cable has a DIN plug at one end, which we can introduce in the DIN modular. The other end has a 3.5mm mini jack for our MP3 player. But first, let's turn the volume completely down. So, like this. Now, let's go for the next round. Now, let's test and explain how the amplifier works. Our smartphone is connected to the DIN modular and is playing some music. If you look at your Lectron circuit in front of you, you can see that current can flow through the preamplifier, but also through the end amplifier. Now, to measure these currents, we need a multimeter. This multimeter can measure voltages and currents. These are the connections for the probes. Let us start with the black probe, which is the ground. This white probe has a detachable 4mm plug. This plug can be inserted in the black connection of our multimeter. This is the ground. The other end of 2mm we will connect to the connection modular at the left of our circuit. Now the ground is connected. Let's move these wires a bit aside. So, to measure the voltages or currents, we need another wire. So we will use a red wire now. This red wire has to be inserted in our multimeter. So we need a detachable plug of 4mm. We will insert it in the red connection of our multimeter. Now, the other end of the wire needs a measurement probe, so we will use the blue one. This blue probe has a very thin metal plate which can easily be inserted between two adjacent blocks without breaking up the circuit. So let's use it to measure. We will set our multimeter to DC setting, about 20 volts. We will use this probe to test different voltages across our circuit. First we have the first amplifier, the second amplifier and the third amplifier. We will also measure the voltage across the voltage divider here, the base emitter junction of the first transistor, the base emitter junction of the second transistor. We also measure the halfway voltage here and the third amplifier of the third transistor, the base emitter junction also. So, now let's power up the circuit by placing the ground cube to the minus of the battery. Now, let's turn up the volume a bit so we can hear the music through our speaker. Right, this should be enough. Okay, now we will use the test probe first to test the voltage of our battery. This should be about 9 volts. Alright, let's move on to the voltage divider here, and the voltage should be reduced. This is about 8.6 volts. Now let's move on to the first amplifier. This is the first transistor in a circuit. It gets its voltages across a 4.7K resistor. We measure the collector and this should be about 1.30. Now let's move to the base emitter junction. this should be about 0.6 volts. See. So, now when we move to the second transistor, now the base emitter junction should be also about 0.6 volts. It gets it by the 100k resistor. We will measure it, and this is also about 0.6 volts. Okay, let's measure now the collector of the second transistor. Voltage is about 4.6 volts. This is about half the voltage of our battery. Let's move on to the third transistor. The base emitter junction should be about also 0.6 volts. This is the emitter. And now when we measure the base, you see the difference is also about 0.6 volts. If we would measure now the connection between the two transistors and the speaker, we will see that this voltage is about 4.7 volts, which is a half of 9 volts our battery. So we can say when the two transistors are conducting equally. This resistor makes the third transistor conduct, and this resistor the second transistor. So the speaker is sitting at medium voltage. It can swing up or down, following the input. Let's turn it up a bit. We will continue now with measuring currents in a circuit. We will measure the current through the preamplifier, through the end amplifier, and also the whole circuit. So, we have to change the probe here. We plug it in the current connection of our multimeter. We set it to current setting, about 20 milliamperes, which is sufficient. So, we don't need this anymore, we need another plug to test. We will use a special Lectron cube. It has two connections at the side and at the top. So this block can be placed between two blocks and break up the circuit. So we will measure current. We will plug the test lead here and just make connection to the side. Now we remove the ground connection of the preamplifier and we use this one instead. Now the circuit will be working. It will measure the currents across the preamplifier. Now let's move on to the end amplifier. So we will place the ground connection back, and now this time we remove this ground connection and we place the block back again. So now we measure the current through the end amplifier. Now we will measure the current through the whole circuit. So we remove the test cube and replace it with the ground cube. So our circuit is working back again. Now we need to add the probe here. This probe is the negative probe of our multimeter. So we plug it here. Now we can place this block between two blocks and the current will be measured. We will use the positive voltage here. And you see the total current is about 9 milliamperes, which is not so much for the whole circuit. But also the volume is not so loud. Just adjusting here a bit. Okay. Now let's enjoy the music a bit. The quality of the speaker has been improved. I've replaced the original speaker with a better one. So the sound quality is much better. Perhaps an idea for you too. Thank you very much for watching and perhaps till later.